Many people know the name Westinghouse because they grew up in a house full of Westinghouse appliances like roasters, dishwashers, and refrigerators. Innovative industrial products and home appliances from the Westinghouse Electric and Manufacturing Company made Westinghouse a household name. But well before their first dishwasher would ever roll off the assembly line, George Westinghouse had to first win the Battle of the Currents against Thomas Edison. Thomas Alva Edison was born in 1847. He was a forceful, egotistic, eccentric creator who had difficulty working with others, all direct contrast to George Westinghouse, who was a military-trained engineer. Edison got his start in telegraphy and invented a stock ticker and other industrial products early in his career. Around the same time that Westinghouse was perfecting the air brake, Thomas Edison invented the phonograph. Whereas the air brake was largely ignored by the national press, the phonograph was hailed as the greatest invention of all time. The phonograph was fun. The phonograph made music. The phonograph was unlike anything 19th century people had seen before, and the population was in awe. Edison became famous and the public loved him, and he loved that the public loved him. He was regarded as the most famous American in the world. He patented the electric distribution system and soon after activated the Pearl Street Electric Generating Station, which provided direct current power to some streetlights and a couple dozen customers in Manhattan. In the early 1880s, America's growing industries were crying for more and more power that was less costly and cumbersome than steam-generated power. The development of electricity was like the rapid development of the automobile, computers, or the internet. Everyone could see that it was useful and amazing, but nobody knew quite how to utilize it or what the standards would be. It could be said that Thomas Edison created the idea of a centrally located power station. The only problem was that the direct current power he was using did not transmit very far.
You could only transmit direct current a few thousand yards from a Edison generating station.
It was quite obvious to George Westinghouse that direct current was never going to be a national model. It's just a local model.
That meant that in order to power a city, he would need power stations every mile or so that were small and practically in their customers' backyards. These facts did not stop Edison from promoting DC power with the theatrics and flair that he was known for. Edison lived in New York City, was politically connected, and loved to put on a good show. He leveraged his fame, his name, and his face to his advantage in business. Direct current power became popular, and Thomas Edison became a leader in the field.
I mean, Edison had the market and built the first power station in New York for transmission lighting. J.P. Morgan actually had the first house that was lit.
In contrast, George Westinghouse did not even like to be photographed. Yet the limitations of DC power were very clear to him. He felt that electric power should be generated in one place and be transmitted to users far away. In 1885, George Westinghouse became interested in the inventions of European inventors Galliard and Gibbs, relating to the use of single-phase alternating currents and distribution with transformers.
George Westinghouse was the first to recognize that you could use a transformer in a large system. With alternating current, you can transform the voltage up to a high voltage, low current, and send it hundreds and thousands of miles at the high voltage and step it back down to the low voltage where you use it. It was the key to the entire system.
He purchased the American rights to their patent and threw himself into the study and design of a new kind of transformer. It was said that he recalled his experiences in the gas industry with the reducing valve that allowed high-pressure gas from the well to be transported over a great distance and then delivered at low pressure at the point of use. The transformer was his reducing valve for electricity.
That's exactly what he was doing with gas transmission, because voltage is pressure. It's the exact same term in electricity as it is in hydraulics and gas fluid. He could step up the voltage to transmit it at a faster speed, and then when he got to the houses, he could step it back down again.
Those who watched him work were stunned at his capacity to do extraordinary things quickly. Through long evenings, he would work in his private railroad car and in his house, designing, sketching, and dictating. When at home, he often worked on his billiard table. It was said he never had a pencil, but just borrowed one from the nearest man. He never returned any of the pencils, and nobody knows what happened to them. One writer said that his trail through the world was blazed with other men's pencils.
He had a unique ability to look at problems and come up with solutions of his own, but he was also willing to take other ideas from other people. If he had to buy ideas or buy patents, he did.
In a miraculous 3 weeks, Mr. Westinghouse and his staff redesigned the Galliard and Gibbs transformer.
Galliard and Gibbs certainly had the idea correct. It was the mechanical part of actually manufacturing and building these transformers that they came up short. It was a rather crude device when Westinghouse acquired it.
The Westinghouse Electric Company was started on March 8, 1886, in the Garrison Alley Works in Pittsburgh.
The Garrison Alley operation was really a research operation, a developmental operation. He was working on a number of projects there, including the transformer.
He was interested in developing ideas into products and products into companies and companies providing employment.
In the beginning, Westinghouse Electric didn't have it easy. Along with research into alternating current, it was about that time that Westinghouse began to seriously compete with Edison in the incandescent lamp business, with a full plant making single-pin lamps, which were a slightly different design than the Edison screw-in bulbs. This was the beginning of the Battle of the Currents. The fierce competition between Westinghouse and Edison for domination in the electrical field would not end for another decade. Interestingly, it resulted in one of the earliest known format wars, between which standard of light bulb and socket would be the dominant one. Customers who chose to go with Westinghouse single-pin sockets could buy this clever adapter to use Edison screw-in bulbs. A few commercial alternating current plants were put into operation over the next few months, but there were still problems. Even though AC power could be generated in large bulk and transmitted many miles away to light cities, there was still no practical AC motor, and thus no practical way to power machines with alternating current. Nikola Tesla arrived in New York City in 1884 with a head full of ideas and barely a cent to his name. He was a brilliant Serbian-born inventor who spoke a dozen languages.
And he came to the United States at the age of 28 with a letter from the director of the Edison Company in Paris that was directed to Thomas Edison, saying, I know of only two great geniuses in the electrical business. You are one, and the gentleman holding this letter is the other one.
Thomas Edison hired him and put him to work redesigning DC generators. The famous story is that Edison offered to pay him an outrageous sum of $50,000 for his work.
And Tesla came to him and said, okay, now where is my $50,000? And supposedly Thomas Edison said, oh, my dear Nikola, you don't understand the American sense of humor. It was the straw that broke Tesla's back, and almost immediately after that, he left Edison.
The brilliant inventor ended up digging ditches for a while, literally, to support himself while he was still creating. In 1887, he constructed the initial brushless alternating current induction motor. A year later, he saw patents issued to him on his motor and on the associated method of transmitting power by polyphase currents.
And when George Westinghouse heard about that, it was like a light went on, an electric light went on, perhaps you might say. This was the possibility where he could see that technology overtaking everything else in the world. And he was right.
Tesla's ideas would enable steam or hydro-powered generators to generate polyphase currents that power induction motors in machines and factories.
The group of patents that Tesla had, which essentially identified the entire path from beginning to end, from the motor to use alternating current to the method of distributing the current and everything in between, it was the answer to the question that George Westinghouse had. Tesla had the answer.
And unlike Edison, who was solely behind DC power, he listened to Tesla. He acquired the rights to Tesla's induction motor and polyphase patents, and Nikola Tesla came to Pittsburgh to work for the Westinghouse Electric Company.
He was also able to back off a guy like Tesla, who had tremendous intelligence, and Westinghouse realized probably more intelligent than him, understood certainly the sophistication of AC current, which was not an easy thing. Today we describe it in differential equations. It's a nightmare for even young engineers today trying to learn that.
Tesla's inventions, combined with Westinghouse's manufacturing skills and his ability to assemble parts of a whole system, brought practical alternating current power to existence. One writer said, "The invention of alternating current motors and the system for operating them was one of the greatest advances ever made in the industrial application of electricity." Not everyone agreed. There was serious opposition to AC power. Assertions were made that the alternating current system was dangerous and that its use should not be permitted commercially. Numerous articles appeared throughout the country designed to prejudice public opinion against the system. One bitter article from a scientist read, "There is no plea which will justify the use of high alternating current, either in a scientific or commercial sense, and my personal desire would be to prohibit entirely the use of alternating current." If anything was needed to urge Westinghouse to greater effort, this antagonism served the purpose.
If we look at a comparison of Thomas Edison and George Westinghouse, we find a number of major differences. They had quite a difference in personalities. An example during the Great Battle of the Currents is Thomas Edison backed the electric chair, not as a humane way to eliminate convicted criminals, but as a way to get a competitive advantage over his competitor George Westinghouse's alternating current. Thomas Edison was trying to discredit Westinghouse's alternating current. He had a campaign to make it look much more dangerous than it really was, although it was dangerous, and obviously this very day we know it could kill people. But George Westinghouse believed electricity was there to benefit mankind and should not be started off by executing condemned criminals. Thomas Edison pushed that in the state of New York and recommended the electric chair as a humane way to execute condemned criminals. And by the way, he said you'd have to use Westinghouse's alternating current. Direct current just wouldn't do it. Now that wasn't exactly true, but that's the position that he pushed. So George Westinghouse was appalled that Thomas Edison would lower himself to that level of competition. When the electric chair was first proposed, there was no term electrocution in existence at the time. Thomas Edison even lowered himself to the point where he suggested that the term to be used would be called Westinghouse. So you Westinghouse a condemned criminal, later to be called electrocute a condemned criminal. Now, so he'd lower himself pretty low at the point of how he was willing to compete.
Edison's connections with the media and politicians worked overtime for him, spinning the evils of alternating current power. It was said that Thomas Edison went so far as to work with a man who electrocuted dogs and cats on stage to give AC power a bad name. Moving footage exists of an elephant being electrocuted in front of a crowd. Although it is claimed to be Edison's work, the film clip is generally accepted not to be part of the battle of the currents. However, it gives an idea of the gruesome, inhumane acts that those men did in order to prove their point about the dangers of alternating current.
Westinghouse came in with a system of alternating current that immediately made the Edison direct current equipment obsolete. And since Edison had provided direct current equipment to a lot of small municipal power companies and light companies, they didn't have money, they didn't have any capital, so he had taken paper. He owned large shares in those municipal companies. He knew that if Westinghouse was successful in replacing all of his direct current equipment that was installed, he would be financially hurt. So that's why he was so anxious to do everything he could to make George Westinghouse's alternating current system a bad word.
After years of costly research, Westinghouse's big chance to show the complex polyphase system and AC power in action would come during the 1893 World's Fair in Chicago. But Thomas Edison would not make it easy for them. The 1893 Chicago World's Fair, known as the Columbian Exposition, was set to commemorate the 400th anniversary of Columbus discovering the New World. It was to be the biggest, grandest, most spectacular World's Fair ever. It would be quite the party and prove to be an interesting event in the life of George Westinghouse. It would also be ground zero for the Battle of the Currents. On May 23, 1892, as the immense fairgrounds were being constructed on the shore of Lake Michigan, the Westinghouse Electric Company won the lighting contract for the World's Fair.
You have to remember how people lived at the time. They lived in darkness. We don't live in darkness at all. Even if you go outside at night, there's light. And whoever wins this bid, if it's going to be Edison or if it's going to be Westinghouse, it's going to mean a great deal because people are going to come to the fair, they're going to see light at night. They're going to be able to extend the day.
The story is that the Exposition Company saved about $500,000 by going with Westinghouse Electric over General Electric. This loss to Westinghouse was unexpected. Thomas Edison had counted on his name and strong patents to guarantee the contract and planned to make a profit at the fair. Westinghouse, on the other hand, would make a risky move by going into it expecting to lose money in order to gain promotion. A gamble that could sink the entire company because of the time and money that went into the polyphase development, leaving the Westinghouse Electric Company in a weakened state to survive the financial crisis of 1893.
Edison at the time represented General Electric, but he had already been bought out. And that battle was a vicious one. Westinghouse finally undercut and won it.
George Westinghouse told his managers, the work must be done right regardless of cost. He said that any loss could be charged to advertising, and that was the main objective.
Hundreds of thousands of people came at night just to see the lighting. And what they do is they go back and they talk about it.
The World's Fair was a massive undertaking, but Westinghouse had the courage of his conviction that his men could do it. He closed the contract before even consulting them. Edison was well known for challenging people on patent infringement, and even though Westinghouse had won the World's Fair contract, they were dangerously close to a patent dispute and a massive lawsuit. The Westinghouse alternating current system was going to power the lights of the fair, but the light bulbs that were going to be used were too similar to a patent owned by Edison, the one-piece incandescent light bulb. Some 6 months before the opening, with all of the Westinghouse work already installed, the patent on the Edison incandescent lamp was sustained, and Westinghouse was not permitted to use the light bulbs that he had planned to use. George Westinghouse had a clever way around this problem, though. Years earlier, he had purchased rights to the Sawyer-Man lamp patent and chose to use those lamps instead, and thus originated the famous two-piece Westinghouse stopper lamp, so called because a piece of ground glass held an iron filament fitted into the bulb like a cork.
Good business sense said he better have a backup, and that turned out to be the two-piece all-glass Westinghouse stopper lamp that was upheld at the court as an independent patent. Perhaps wasn't as good an incandescent lamp as the Edison lamp at the time, but it was good enough to successfully illuminate the Great Chicago World's Fair in 1893.
Westinghouse rushed through extensive new production facilities to finish the bulbs the moment the fair was scheduled to open.
The Westinghouse Company at that time manufactured 250,000 two-piece all-glass Westinghouse stopper lamps. It was estimated at the time that was 25% of all the incandescent lamps made up to that point in time anywhere in the world.
It was a quick and dirty job, and the opening of the fair on May 1st, 1893, was not delayed an hour. In his tradition of surrounding himself with smart people, Westinghouse was well served by his patent lawyers and engineers. The World's Fair lamps did not last long and had to be changed often. But fair visitors never knew this at the time. All they saw was the beautiful lighting and the name Westinghouse. The fair was a huge success, attracting nearly 28 million visitors in its 6-month run, and the Westinghouse exhibits had prime real estate. Just off the Court of Honor sat the massive electricity building, which was one of the most popular attractions. The Westinghouse Electric and Manufacturing Company occupied a huge chunk of floor space right alongside their rival, General Electric. In Machinery Hall, the Westinghouse Electric Company showed off their complete polyphase system. The generating plant for the World's Fair lighting was the largest alternating current central station then in existence. To further amaze visitors, the complex switchboard used to control all of the machines required only one operator. George Westinghouse attended the fair that summer, but left all the planning and construction of the exhibits to his managers. Mr. E. Keller, the Westinghouse manager of the World's Fair contract, said, "Like most of his helpers, I felt ready to march through fire for him and was amply repaid. Such was the man, Westinghouse." In the end, they even turned a profit of $16,000, not including advertising.
I'd like to have been there. That would have been a great experience to have walked through that place, but I understand no one person could see the entire fair during the summer, that there was so much to see.
Many believe that the greatest single thing to come out of the Columbian Exposition was not Cracker Jack or the Ferris wheel, but that it finally settled the AC versus DC battle of the currents once and for all. The World's Fair helped Westinghouse win one of the most important contracts in history. The hope of harnessing the tremendous power of Niagara Falls had been a dream of scientists and engineers for decades. Top minds like Lord Kelvin and Thomas Edison were involved, but by the fall of 1893, the project remained stuck in the mud, suffering from the bitter controversy over whether alternating current or direct current should be used. It was the impressive display of AC power at the World's Fair that gave Westinghouse just the edge he needed, and even skeptics like Lord Kelvin, who was once on the DC side, gave in.
People came into the fair remembering the name Edison. They came away thinking Westinghouse.
It gave the publicity that George Westinghouse needed to really put in position his ultimate goal, which is also Tesla's ultimate goal from childhood, to put the power system into Niagara Falls.
Now all the power could be generated in one spot and transmitted many miles away with the help of transformers. On October 24, 1893, Westinghouse Electric was awarded the contract for 3 5,000 horsepower alternating current generators for Niagara Falls. The first hydroelectric generator unit was tested on April 16, 1895. A year later, 3 seconds after midnight, on November 16, 1896, Buffalo, New York was receiving power from the mighty Niagara Cataract for the first time. The battle of the currents had been won by Westinghouse.
It was such an event, and Tesla was there and spoke. I know he spoke at length. I understand from some newspaper comments, he spoke at excessive length.
And pieces of the original power line from the 1895 test were saved to honor the occasion. The Westinghouse Electric Company finally started seeing returns on their enormous investments into alternating current and the polyphase system. Orders began to flood in. The original Niagara Falls generators were joined by the addition of 7 similar units a few years later. Today, newer plants and technology continue to harness the hydroelectric power of Niagara Falls.
Later in life, Nikola Tesla was quoted as saying the only man in the world that could have pulled off alternating current was George Westinghouse, for he was the only man that would come up against Thomas Edison.
Even though the battle of the currents may have been over, the fierce competition between Westinghouse and Edison continued.
It's well known today that Thomas Edison had 1,093 patents during his lifetime. History also records that George Westinghouse is credited with 361 patents during his lifetime. But again, understanding the differences in their personalities has a major impact on how many patents each was granted. It is well known and well documented that if you are a worker that worked on an item that was patented and worked for Thomas Edison, the name on that patent was Thomas Edison. It's also well known and well documented that if you were a worker that worked for George Westinghouse at the time and had worked on an item that was patented, the name on the patent was that of the employee or the worker. Benjamin Lammy, for example, one of the great Westinghouse engineers, perhaps best known for having designed the first 3 5,000 horsepower generators that went into Niagara Falls. Benjamin Lammy alone had 162 patents during his career at Westinghouse. Every one of them recorded it in the name of Benjamin Lammy. So I always thought if we could get all these patents of all the great engineers and others that worked for Westinghouse, if he had the same practices as Edison in putting his name on those patents, he'd have well in excess also of 1,000 patents during his lifetime.
George Westinghouse always surrounded himself with the best and the brightest.
He had a real knack as a manager that Edison didn't, in that he could bring a lot of very creative, very intelligent people together and at least get them to work towards a project. And these people were hard to bring together. They had big egos, and he was able to manage that. He was a tremendous manager, something that Edison was not, and most inventors are not.